in this example we have a circuit with a pair of coupled coils having the following having this arrangement: 2 Henries, and let this also be 2 Henries self inductance, and let the mutual inductance between these two coils be 1 Henry. Let the element values be as marked here. These two are current sources, DC current sources, 1 ampere and 2 amperes, and the switch is kept open for a long time and closed at t equals 0. You are asked to find I2 of t. Find I2 of t for t greater than 0, greater than or equal to 0. So, let us see, as far as this inductor is concerned, it does not carry any initial current at t equals 0 because the switch is open. Therefore, if we call the rho 2 to be the current here, it is 0. As far as the first inductor is concerned, this 2 ampere current source, DC current source, flows entirely through this inductance because under steady state the voltage here is 0. Therefore, this 2 ohms is short circuited. Therefore, rho 1 is 2 Henries. So, from the statement of the problem, we know that rho 1 is 2 amperes, that is the current in this inductor at t equals 0 minus the current in the second inductor is 0 amperes. So, that is what we are having. So, if you set up the transform diagram for this, you have corresponding to the 2 amperes DC source, you have 2 by S, that is the current source in the transform domain, and you are having 2 the generalized impedance of this resistor, and you are having self inductance 2S, and since the initial current here is 2 amperes, I can replace this by an equivalent current source of 2 by S in the second representation which we have just now discussed. And these two inductors have the same self inductance and a mutual inductance which is equal to S in the transform domain, and once the switch is closed here, you have this 2 ohms and then the current source here. You should not put the current source as 1 here, but 1 by S because that is a DC source and we are talking about the transform domain. All the variables here are transformed variables. Now, in this we are interested in finding out I2 of S. This is the what we are after. Observe here that 2 by S and minus this 2 by S coming together at the same node cancel each other out. That is, if you have a current source here of some amp, say Ix, and another current source of Ix here, so they both of them cancel each other out, and therefore the net current in the whatever to which is connected is 0. So, using this principle here, after all this current source and this current source are parallel to each other and equal and oppositely headed. So, their effect on the rest of the circuit is negligible, is 0. Therefore, I can write this simply as 2, this is 2S, and a coupling of S between these two, and you have 2 of S, and you have 1 by S as the current source, this is 2, this is 2S. So, that is what we are having. So, we can suppose I like to use the loop current method of analysis, they can convert the current source in parallel with a resistance as a voltage source in series with a resistance. So, this is equivalent to 2 ohms, 2S, this is 2 again generalized impedance 2 ohms, 2S, coupling term of S. Now, a current source in parallel with a resistance can be replaced by an equivalent voltage source in series with a resistance, and the strength of the voltage source, just as you use Thevenin Norton equivalents that in DC circuits, the multiplication of these two, this becomes 2 by S. So, you have a voltage source 2 by S in series with a generalized impedance 2. So, if I write the two loop equations as loop currents as I1 and I2, the current here is what we are interested in, that is the same as I2, the current in this coil, therefore, the identity of that current is retained, and you write the loop equations for this. So, I can write this as 2s plus 2, I write these loop equations in matrix form because they are quite simple and easy to visualize. So, I write this I1 of S and I2 of S, and on the other side I write the forcing functions. Therefore, the first loop equation is 2s plus 2 times I1 of S, 2s plus 2 times I1 of S, and this the mutually induced voltage I1 is entering the dot point and I2 is leaving the dot point. Therefore, the sign of the mutually induced voltage is negative, and the multiplication factor is S because this is the mutual impedance. S times I2 is the magnitude of the mutually induced voltage, but we have to have a negative sign, therefore, minus S times I2 of S, and the total driving voltage in this loop is 0. Now, for the second loop, the self induced the self impedance of this loop is 2s plus 2, and the mutually induced voltage again I2 is leaving the dot point and I1 is entering the dot point, therefore, the sign of the mutually induced voltage is negative. The mutually induced voltage has a Laplace transform S times I1, but the sign is negative, therefore, minus S times I1 plus 2s times I2 of S. That must be the net voltage in this loop trying to drive a current in the direction of I2, but the total EMF in the circuit is 2 by S in the opposite direction, therefore, I must write this as minus 2 by S. So, these are the equations which describe the behavior of this circuit on the loop current basis. You can solve for this and you get an expression for I2 of S. The solution of these two equations will give you I2 of S equals minus 4 upon 3 S plus 1 over S times S plus 2 by 3 times S plus 2, which on partial fraction expansion will yield minus 1 by S plus half divided by S plus 2/3 plus half S plus 2. So, that is the partial fraction expansion of I2 of S, and therefore, you can write I2 of t as minus 1 plus half e to the power of minus 2t by 3 plus half e to the power of minus 2t, and the entire quantity is of course multiplied by ut. That is the expression for I2 of t. So, you can see that the solution for the transient problem of this sort once again can easily be handled with the transform diagram approach. You do not have to write the differential equations, and once you have the transform diagram, you write the equations of performance in S domain in the same way as you would do for DC circuits, and once you get the solution for the required quantity in terms of transforms, you have to find the inverse transform to find the pertinent quantity in time domain.